Cool. So we're going to move on with our next speaker here. Erin Delventhal will be telling us about pseudomorphs and giving us kind of an overview of the whole idea of what is a pseudomorph. Erin is very involved in the mineral community. She's a lifelong mineral collector, but she's been involved in just so many things. Officers in various clubs, her GIS work, her photography, her design work has showed up all over the place in the mineral world. You might have seen some of her art at Mineral City in Tucson. She's just got stuff all over the place. And I'm really excited to have her tell us today about pseudomorphs.
Thank you. Hi, thank you guys for having me. So one of the earliest problems that I encountered when I was studying pseudomorphs is that the question, what is a pseudomorph, will be answered differently depending on who you ask. In looking at the history of the study of pseudomorphs, it also depends on when you ask. Max Jo's Lapis article on the history of pseudomorphs uses the phrase das Pseudomorphosen Problem, and I think that's perfect because the entire topic is nothing but problems. So we're going to look at what 23 sources have to say about what a pseudomorph is. This is not all of the existing literature by any means. Previous work by Cyan Fraser and Charles Shu has provided an excellent foundation, but this is a work in progress for me, especially because I'm working from my own translations. I am sure that there are errors in my work because, in full disclosure, I do not speak German or French. In that, I also apologize for any bad pronunciations. Now, I put more emphasis on the early history, so we're going to see a lot leading into about 1860, and then I'm just going to cover some large developments past that. Now, in terms of accessing some of these older texts, the Munich Digitization Center has scanned copies of nearly every text that I went looking for. If you need old German texts for any reason, I really recommend taking a look at this. The Rock H. Currier Digital Library on Mindat also has a number of texts now, and that's continuing to grow, so keep that in mind. There were a few texts also from the Internet Archive and from Google Books. The other note that I want to leave you guys with is the photos of specimens are so that you have something to look at while I'm talking about history. They don't necessarily correlate to the information on the slide, so if you can't find a connection, there probably isn't one. Don't stress yourself out. So the history of pseudomorphs often starts with Franz Joseph Anton Essner, and he's cited as the first recorded use of the term after crystal. We're going to come back to Essner because we first need to lay some groundwork around the term after crystal and the problem of Abraham Gottlob Werner. There have been multiple names used for pseudomorphs over time. The German after crystal is the first known term for the phenomena, followed by the French pseudomorphs, the English spurious crystals, the Scottish supposititious crystals, and later the Germans returned to add metamorphic crystals. The claim that Werner was the first to notice after crystals, and even that he coined the name, is pervasive. The use of after crystal is related to a section on the essentiality of crystals, true essential crystals in contrast to false after crystals. Now, one of my problems is that I'm plagued by a compulsion to check the original source, so I went looking for this. Now, a little background on Werner. He shows up in Leipzig and spends the following year preparing the 300-page treatise on the external characters of fossils, which becomes the first modern textbook on descriptive mineralogy. It was published in 1774. Werner was 25. This book lands him a job as a professor at Freiburg, where he becomes an even more monumentally influential figure. Werner's list of students is long, and his ideas are widely propagated, leading to his reputation as the father of German geology. He has a lot of connections, but instead of pointing out each of those connections, I've just marked the lower corner in red. So if you see a red corner, that's somebody that had very obvious ties to Werner. There may be some that I missed, but that should give you some ideas. So you can track his presence in the ideas by just keeping an eye on that corner. So he leads this work with a paragraph, mentioning specifically that he has taken the liberty of expressing in it his thoughts on the deficiencies of mineralogy in general. And just make note of that because it's very funny in context of everything that comes next. There isn't much else to say about this work because the section on the essentiality of crystals does not appear in it. Now, 16 years later, Claudine Picardy publishes the first French translation of Werner's work. Some will say that this is the first translation, but Shu lists an 1784 Hungarian translation as well. That would have been the first. We're going to talk about the second one instead because that's a woman in 1700s science, and that's exciting. Now, there's a lot to say about Picardy. I can't chase all of those squirrels today, but if you want to read a little bit more about her, I recommend this article in Pour la Science. It is in French, but you should be able to use your browser to translate it and get the gist of the article. In relation to our discussion today, I think it's likely that her translation allowed Hui to read Werner's work. She was the first to bring German geology to France. She also serves very well to illustrate the problem with Werner. So she writes that the Spanish chemist de Luyar passed through Dijon and reported to her that Werner was in no way thinking of giving a new edition and that he was busy. To his credit, he is legitimately busy. At this point, he's translating Constant. For a period of time, he gets very interested in trying to standardize colors well ahead of Pantone. Plus, he's got all these students. But this is the problem. Everyone has been begging Werner for an update to his work, and he continues to not do that because he's busy doing other things. Picardy decides that she will not only translate Werner's work, but also use his notes to correct and add to it. This resulted in enough changes that she suggested that it may be regarded as a new edition. She will not be the last to do this, and she may not even be the first. A whole article could be made about Werner being busy. I came across at least 5 authors that listed their reason for writing as Werner was too busy and I had to. However, once again, the section on essentiality of crystals does not appear in this work. In 1805, 16 years after Picardy's translation and 31 years after it was originally published, the English get their first translation of Werner by the hand of Thomas Weaver. Werner has still not published an update, so Weaver makes the same decision as Picardy. He attempts to supply the deficiencies of Werner's first edition by using Werner's corrections, notes from his students, and works authored by his disciples, Windeman and Emmerling, amongst other things. In Weaver, we finally see the section on essentiality of crystals and the word after crystal. Now, to repeat myself, this section does not appear in Werner's first edition. It does not appear in Picardy's translation. It is variably modified and removed from later translations. This section also appears in similar forms in other works, both earlier and later than Weaver, so he's not the origin point of this. The earliest I have found it is in 1794. Now, also note that Weaver uses after crystal as a synonym to the primary name spurious crystals. In 1962, Carozzi publishes another English translation. This text has a really great introduction that talks about the history of Werner's translation. So if you want to read any more about that, I recommend taking a look at this book. That's on the Mindat library, so you can access that for free. Now, the University of Illinois had purchased the original personal copy of Werner's 1774 edition alongside his notes, addenda, and errata. Using this, Carozzi and his team create what would have been the second edition if Werner had succeeded in getting it ready for publication. The translation does not contain the section on the essentiality of crystals. Now, there technically was a second edition published in 1785. So this is early. This is before Picardy's translation. It's 1 year after the Hungarian translation. So apparently it didn't satisfy any of the complaints that people had about needing a new edition. It also does not contain after crystal. I checked that one too. Werner published very little over his life and never gave the update that he was asked for. Now, I can't prove Werner didn't coin the term after crystal, but I'm a little skeptical. I think it's likely that the word comes from within his sphere of influence, but he had colleagues, he had students, and a lot of their work might have been swept up into his reputation. Now, there's also a citation given by Henning in 1949 and repeated by Shu that suggests that Goethe coined the term after crystal in 1792. Goethe's problem is exactly the opposite of Werner. He can't stop writing. Goethe was so prolific that his work was used to compile one of the major German dictionaries. The citations used to support this point back to German dictionaries. The source used by the dictionary is an addenda to Goethe's work published in 1904. The date 1792 is likely taken from the column heading that's referring to a publication by Karsten. The line item containing after crystal appears a few pages later. Galmi is a synonym for calamine. Now, I'm honestly not entirely sure what this list is because the item immediately above this is something about lining the drawers in blue. And it's kind of just a random list of there's minerals and all sorts of stuff in it. But it doesn't support verticoiting after crystal. Now, I thought maybe it could be something out of Karsten's work, but that doesn't fit because if you look 2 items above, there are publications listed from 1794 and 1796, and I just don't think Karsten can see into the future. Fortunately, this doesn't really matter because I found something that predates it. So while I was looking through the Munich Digital Library, I found a 1790 source using after crystal. That predates Essner by 4 years. This item is just a casual mention of Chert after crystals. This appears in the Göttingen Scholarly Ads. It's a German academic journal that's actually still published today, which is kind of incredible. And it's under a review of Karsten's 1789 publication on the contents of the Leskian Museum. Now, I did locate this text. I haven't checked it yet because I don't know what page it's on, and that makes translation a little bit problematic. There is an English translation that I'm going to use to find the page number. I just haven't done it yet. So we're going to just use the 1790 date, although likely it pushes back to 1789 instead. So I just want to look at the phrasing of this entry. Also considers, indicates that this is already a point of discussion. People are talking about this. This term after crystal, it's already in common usage. So this is definitely not the earliest date. As we find more sources, this will continue to get pushed back. So we can return to Essner. Essner publishes an attempt at mineralogy for beginners and enthusiasts in 1794. Essner has some thoughts about how these crystals might form. Bloom, one of our later authors, makes a comment that I think is a little bit of a dig at Essner about his ideas being adventurous. And then we'll see the second part talking about incrustations on other minerals. That's not out of the ordinary. The first part, though, where we're talking about a crystal hardening first as an outer rind and then the core is infilled or left hollow, that's a little weird. Oddly enough, though, there is a type of crystallization that forms as shells and crystallizes inwards. And I don't know that this happens on any large scale or that it necessarily has anything to do with pseudomorphs. I think it's pretty much guaranteed to be a coincidence, but it would be amusing if Essner was 2 centuries ahead of his time. And it's interesting, I love the part in Terry's last talk talking about, the tube structures, because technically that's also a shell that gets filled in later. So that's another way that this actually could happen. Now, again, thanks to the Munich Digital Library, I found another new text published the same year as Essner. This is the Handbook of Arictognostic Theory of Mineralogy by Windeman. Note that Windeman is one of the disciples of Werner used as a source in Weaver's translation. And this poor guy, he publishes the same year as Essner. He's referenced a couple times in later papers, but overall he seems to have gone largely unnoticed. I've seen at least 4 different spellings of his name. He states in the intro that he published this because Werner's been too busy. The section on essentiality of crystals is in this text. Windeman offers a classification scheme. This is the earliest that I know of. He groups after crystals by method of formation into 2 categories. 1, a mineral solution infilling into a regular space, and 2, an external crust on a mineral with or without the removal of the original crystal. So we're going to see these again. Let's make sure that we're just all on the same page here. Infillings are typically regarded as cases where an enveloped crystal, maybe in a solid matrix, for example, has been removed by some mechanism. Has been removed by some mechanism to leave a hollow mold in the matrix that is later filled in by another mineral. The infilling is the resulting cast. And I hear this used backwards pretty often. Molds are the hollow forms. Casts are the resulting solid after that form has been filled. Incrustation doesn't really require a lot of explanation. Something forms a crust over something else. Now, I have seen some people get very angry about the inclusion of incrustations as a pseudomorph. So I just want to point out that they have been included from the very beginning. So in 1801, Hui publishes his Treatise on Mineralogy, which is a monumentally influential work in the development of mineralogy and crystallography. In this, Hui describes a subtype of concretions, which he calls pseudomorphoses. This is the first known use of the word pseudomorph. He describes them as bodies that have a false and misleading figure, which they have somehow stolen from other bodies. I take a little bit of offense at the accusation that pseudomorphs are thieves, but this sort of rhetoric will persist. He then goes on for 2 pages talking about shells. And the word he uses, la coquille, is typically used exclusively for seashells. So he is talking about organic fossils here. He makes an interesting comment that if a seashell has had its material replaced by another, like silica, and it remains hollow, that's not a pseudomorph. So disregarding for the moment that he's talking about shells here, quartz replacing, calcite or aragonite now would certainly be considered a pseudomorph, yet Hui seems to indicate that that needs to be filled in order to count. After his discussion of fossils, he chimes in at the end to mention that the mineral kingdom also has pseudomorphs. His usage of pseudomorph is predominantly used for fossils. Minerals are simply an afterthought. What you see here is the entirety of what he has to say about mineral pseudomorphs in this text. Now, as we saw earlier, Weaver publishes his translation of Werner in 1805. He distinguishes genuine crystals from spurious or after crystals. He does not accuse them of being thieves, but implies that they're freaks of nature instead. He also classifies spurious crystals by method of formation, incrustation, and infilling. He requires incrustations to be hollow and for infillings to be separated from their enclosing mass. Weaver gives some description of the differences in characteristics between genuine crystals and spurious crystals. One comment I thought was interesting. Genuine crystals are connected by transitions with other crystals of the same constituent principles, whereas spurious crystals have only casually taken another form and there is no relationship. This is backwards from what most people will argue today. In the same year, another treatise on the external character of minerals in English is published by the Scottish mineralogist Jameson. Jameson is a devout follower of Werner. He helps found the Wernerian Club with the aim of promoting Werner's ideas. This text is of obvious Wernerian thought. The title is the same, yet this is not described by Jameson or anybody else as a translation, so I'm not really sure what's going on with that. He doesn't make any comment, but maybe he got impatient waiting for Werner to make an update. Jameson uses supposititious crystals in place of his English counterpart spurious, and once again categorizes by method of formation into infillings and incrustations. In 1811, Hoffman publishes his Handbook of Mineralogy. He states that his intent is to purify Werner's thoughts from all the incorrect additions that have been made by others, an attempt to remedy a deficiency. This work is cited by Bloom as the evidence that Werner coined after crystal, but there's no direct mention of Werner in the section or leading into the section on pseudomorphs. He's mentioned in the next section, but it's about the shapes of crystals, which is not really the same subject. Again, the after crystals are classified by method of formation, infilling and incrustation. Hoffman allows for both to be either solid or hollow. Now, in the same year, Steffens publishes his complete Handbook of Eryctognosy. In this, Steffens discusses the debate around the steatite pseudomorphs. These were a problem. As seen in this disagreement between contemporary scientists, nobody agrees. And he gives us a little bit of insight into the problem by noting the changes in bodies composed of multiple minerals, describing it as similar to a contagion that annihilates all differences between multiple different minerals in the same rock. He then acknowledges that the current science cannot explain it. The problem, and this problem will persist, is that there are examples of after crystals that cannot be explained by infilling or incrustation. Nobody agrees because nobody can supply the deficiencies. He makes a bold assertion that all crystalline forms of steatite are formed by metamorphosis. This idea will shake things up. Now, in 1815, Breithaupt publishes On the Authenticity of Crystals. This is the first known monograph on pseudomorphs. He classifies after crystals by the same methods of formation, infilling and incrustation. He includes both solid and hollow incrustations. However, referencing Steffens, he also makes a class for a third class of crystals, metamorphic crystals, which were changed in composition but preserved in mass and form. He classifies these as a separate but intermediate class between the essential crystals and after crystals. And while describing limonite after pyrite crystals, he suggests that the mechanism of formation could be chemical, but asks for further insight from chemists to confirm if this is possible. In 1822, Mohs publishes his basic outline of mineralogy. Now, Mohs distinguishes only one mechanism of formation, infilling. There is no chemical connection in pseudomorphs, and coatings do not count. Also note that Mohs, despite having studied under Werner, has abandoned after crystal in favor of pseudomorph. Of the sources that I've included in this talk, we will not see after crystal again. Mohs is also the last associate of Werner that we will see. Werner died in 1817. Now, in 1828, Naumann publishes his textbook of mineralogy. His definition of pseudomorph uses mineral aggregates instead of mineral, which I really like because it is entirely possible for multiple minerals to replace a primary form. He continues with the ideas of Steffens and Breithout that crystals can undergo transformations, but adds that as a third type of pseudomorph rather than a distinct category from it. He has more to say, but unfortunately the copy of this that I found is badly scanned and is mostly illegible. I need to find another copy of it. Now, in 1837, our American hero, James Dwight Dana, joins the conversation with his first edition of A System of Mineralogy. Dana classifies by three mechanisms of formation: infilling, incrustation, and replacement. Of replacements, he comments that the process by which they are formed is often very obscure, then offers reasoning for a process in which one mineral is slowly eaten away by a solution while another is deposited gradually in its place. I think the idea of this having some common chemistry is derived from the thought that the dissolved components would mix into the fluid that's depositing new components. This is offered largely as an alternative to the idea of metamorphosis proposed by Steffens and Breithout. Everyone is trying to explain these pseudomorphs that have no common chemistry, but that cannot be infillings or incrustations. This debate will rage for decades. Unlike Mohs, who thinks that all pseudomorphs are infillings, Dana is skeptical that infilling pseudomorphs exist at all. This is another problem that will repeatedly come up: the process by which an enveloped crystal would be removed without affecting the enclosing mass and then the void filled with another mineral. It's too complicated. Everybody wants a different explanation for this. In 1841, Landgrebe publishes On Pseudomorphoses in the Mineral Kingdom and Related Phenomena. Landgrebe rejects Breithout's class of metamorphic crystals as unnecessary, but using the same imagery as Steffens of the change resembling an infection, he agrees that there's something more than just infillings and incrustations. He also notes that this change can happen not just from the outside in, but also from the inside out. Landgrebe divides pseudomorphs into molding, grouping, incrustation, and infilling together, and transformation, which all have some chemical relationship. Those without release or absorption of substances occur strictly between dimorphic minerals, so these are what we call paramorphs now. He is also skeptical of infilling pseudomorphs and suggests that probably that's what the steatite pseudomorphs are. In 1843, Bloom publishes his Pseudomorphs of the Mineral Kingdom. This is a monumental contribution to the study of pseudomorphs. It contains not only discussion of the mechanisms of formation, but as Metz later describes, hundreds of pseudomorphic mineral formations and their locations are described in detail and lovingly. Bloom will add 4 supplements to this work over the course of his life. He argues for classifying pseudomorphs by whether or not there is a chemical connection between the original substance and the resulting pseudomorph. Bloom acknowledges that some pseudomorphs contradict all chemical knowledge. To address the problem of pseudomorphs with no chemical relationship, he suggests that maybe mechanical processes are responsible. Using those thoughts, he classifies pseudomorphs into transformation pseudomorphs, those with a chemical relationship, and replacement pseudomorphs, which are those without. Note that Umwandlung translates as transformation or conversion. Verdrängung translates to replacement or displacement. Now, by replacement, he means a process by which a mineral is replaced by some mechanical action rather than a chemical. In the debate over whether the problematic pseudomorphs are replaced by chemical or mechanical processes, Bloom adopts both. He's also another skeptic of infilling pseudomorphs, which he says certainly never took place. He echoes Steffens and others, declaring that science is still not sufficient to explain pseudomorphs. There are still deficiencies. Dana returns to the subject 8 years after his first system of mineralogy with a short article called Observations on Pseudomorphs. His first 3 categories are largely the same. Incrustation now requires the removal of the original crystal. Replacement used to have common chemistry, but he's changed that to no interchange of elements. However, he does state that He does state that this process is in a certain sense chemical, talking at some length about the type of fluid that could achieve this. He makes 2 additions: transformation pseudomorphs, those with chemical exchange by addition, loss, or exchange of constituents. Those are added under the title alteration. He has also added allomorphism to address changes between dimorphs where the chemistry does not change. Now, Naumann publishes again 18 years after his first commentary on pseudomorphs, and he's made some changes as well. Before, he had distinguished 3 categories: infillings, incrustations, and metasomatic pseudomorphs. He has reorganized those into hypostatic pseudomorphs, those formed by deposition on their surfaces, and metasomatic pseudomorphs, which are those formed by substantial transformation. Hypostatic pseudomorphs can form inward, outward, or both. Metasomatic pseudomorphs are those that involve the loss, absorption, and partial exchange of constituents. Now, there's still problems, though. Naumann categorizes the replacement pseudomorphs as both inward replacing hypostatic pseudomorphs, but also as metasomatic pseudomorphs. They can't get everything to fit. Now, as an aside, this publication is the first time that I saw use of the abbreviation PS for pseudomorph. It's not used here in the same way that we use it on labels now, but you can see why the abbreviation was adopted. UPS is an abbreviation for Umwandlung Pseudomorphosen, which is a little bit of a mouthful. In 1854, Dana publishes the 4th edition of a system of mineralogy, which contains updates to the pseudomorph section. He summarizes the history of the study of pseudomorphs, describing the current state of knowledge as that they are types and evidences of vast metamorphic changes and processes of decay or reformation in inorganic nature. And if you compare his 1845 classification to 1854, he's reordered the items. He's moved infiltration into a subtype of incrustation. Replacement is now called substitution, and allomorphism is called paramorphism. If you haven't noticed by now, terms like replacement, substitution, transformation, etc., are used interchangeably over time to mean completely different things, and it's very confusing. Now, in 1859, Deleuze publishes the article Researches on Pseudomorphs. This is often cited as being authored by M. Deleuze, but I think that's a mistake and is probably referring to Monsieur Deleuze. If you go looking for it, I think you need to use the M because that's what everybody uses, but that's not his name. He equates pseudomorphism with metamorphism, distinguishing them as the change in minerals as opposed to the change in rocks. Deleuze's first concern, and one that he gives 17 pages to, is that envelopments are not pseudomorphs, but associations of minerals. Now, the examples he gives of this are a little bit interesting. Tourmaline with green exteriors and red cores, concentric zoning in lucite, idocrase intergrown with garnet. All of these are cases of chemical changes during growth. He mentions kyanite enveloping starlite and vice versa, which is typical of metamorphism, and cases where quartz envelops barite and vice versa. That's what I would imagine as an actual envelopment. Now, after discarding the envelopments, Deleuze classifies pseudomorphs as alterations in which the mineral still contains elements of the original substance, displacement in which that's not the case, and paramorphs, which are the dimorphic transformations. He seems happy to include fossils as pseudomorphs and points out that the formation of both take place by the same procedures, even if we still don't quite understand what those procedures are. Now, in 1871, after a year of serving as the president of the American Association for the Advancement of Science, Hunt offers a 50-page manifesto. He insists that there is absolutely no proof that pseudomorphs by alteration can happen, and that they are all easily explained as envelopments, which, as we saw from Deleuze, don't count and are merely associations, and so we can throw those all out. Quoting himself, arguing with Biscoff and Dana, he argues that most cases of pseudomorphism are purely imaginary, and when they are real, they are merely accidental and localized. Now, discussing the formation of these envelopments, he brings back the wild idea we saw back in 1794 from Essner, where a shell of a crystal is formed first and then fills with other matter. I haven't quite figured out what Hunt's problem is yet. There's some connection in all of this to the split between the Neptunists and the Plutonists, but I need to dig around a little bit more on that. However, Hunt is very opposed to the idea of most pseudomorphs. He's a true hater. Now, in 1902, Pelikan publishes the article Pseudomorphoses of Magnetite and Rutile to Ilmenite. In it, he describes the cross-section of an ilmenite crystal that shows an irregular core of rutile within a shell composed of a mixture of rutile and magnetite. He suggests that this should qualify as a pseudomorph. He notes that it doesn't fit into any of the existing classifications, proposing a new category be added for segregation pseudomorphs. These are pseudomorphs that are formed by exsolution, where multiple minerals will separate out from a solid solution after crystallization. Magnetite and rutile after ilmenite are a great example of this, but another one is perthite in feldspars. In 1935, Frondel publishes the Catalog of Mineral Pseudomorphs in the American Museum. Now, I'm a big fan of what Frondel does here. He leads with a standard but narrow definition: a mineral that has taken the place of another mineral by some action. I would argue with this, but I don't have to, because Frondel immediately argues himself out of it. That definition excludes hollow molds, fossils, boxwork structures, and more, but since those things are all bodies which reflect a previously existing surface, he argues they ought to be included. Further, to avoid confusion, he suggests extending the definition to include any substance or structure of definite or characteristic form which is represented or defined by another substance to which the form does not properly belong. I adhere to this general philosophy personally, except for one small modification. Frondel includes everything except incrustations in which the original mineral is still present. I think those should be included too. Now, Frondel does not attempt to build a classification scheme for all pseudomorphs. Instead, he creates a descriptive scheme. This is very clever because you can start to see these relationships between these different types of pseudomorphs. He then goes on to give the catalog of the American Museum using this schematic. So, for example, you cannot have a pseudomorph formed by the removal of a crystal if the crystal was not already encased in something. Therefore, a removal can only ever pair with two originally enveloped crystals. Other items can pair with multiple things. Now, Jolie and I are looking at whether there's a way to map these relationships using Frondel's data. I hope to have an update on that by Denver. So come back for more. Now, he does spend some time discussing the formation of substitution and incrustation pseudomorphs. This has something to do with new ideas about peptidization of particles into colloidal suspension, where they're then adsorbed, not absorbed, onto existing surfaces. He comments that the ability for this to happen on a large enough scale to produce pseudomorphic specimens might be explained by the recent discovery of the mosaic structure of crystals. Now, in 1964, Metz publishes the article, Pseudomorphoses, True Crystal Figures. He uses many familiar categories. We see paramorphs, transformation and replacement pseudomorphs. He's differentiated those as partial alteration of the material content versus complete replacement of it, envelopments and infillings, which he has given separate categories. Pelikan segregation pseudomorphs or demixing pseudomorphs have now been added. I can't say that Metz was the first to do this, but he is the first that I've seen to do this. I did not see those in Frondel. Now, in 1982, Struens publishes a comprehensive article called Pseudomorphoses, the Current State of Knowledge. This is the grand culmination of everything that came before, and I think it's roughly where our knowledge as collectors kind of currently sits. He classifies pseudomorphs into 4 types: paramorphs, which have no material change, only structural change; demixing pseudomorphs, which have no overall change, but change by separation; replacement pseudomorphs, which involve material change through chemical relationships, and paramorphosen or incrustation pseudomorphs, in which there is no relationship between the resulting mineral and its precursor. Now, comparing METs to strunts, the schematic has been simplified, but it's also been expanded in scope. Within paramorphs, Struens has added polytype transformations and metamixed minerals. Demixing pseudomorphs has stayed the same. Where METs distinguish transformation and replacement by partial versus complete change, Struens groups them together as just varying degrees of replacement. Enveloping and infilling pseudomorphs are grouped together under paramorphs with a slight caveat. Regarding infillings, where an empty cavity is infilled, Struens quotes Bloom that the process certainly never took place, only to add that they may exist. Now, in 2009, Blicken published the text Polymineral Metasomatic Crystallogenesis. This is an English translation of a body work conducted since the 1980s by Russian scientists, the author being one of them. It addresses metasomatic crystal replacement, mixed crystal formation, and epitaxy, amongst other things. In the introduction, the comment is made that polymineral crystallogenesis is characterized by a number of characteristic features that cannot be explained within the limits of classical theory. The current science still has deficiencies. In this, they propose that polymineral metasomatic processes should be classified by their degree of spatiotemporal correlation. I don't know if this works. It's a really difficult read, and honestly, I don't understand it. The idea of introducing time as a factor is very intriguing, though. That is an essential part of a pseudomorph. Something first existed, and then later, after some amount of time, it has changed. This is also in stark contrast to the previous work we have looked at, which sought to find order within mechanism of formation or common chemistry or some blend of the two. So in answer to the question, what is a pseudomorph? Well, it depends on who and when you ask. Many different phenomena have been variably included and rejected by different authors over time. I think it's likely that we still don't fully understand it. I think there are probably still some deficiencies. Cy Fraser makes a comment in his 2005 article that I think is helpful. The collector, of course, is always free to keep or discard whatever parts he or she chooses. If you don't like it, don't put it in your collection. It's fine. For what it's worth, this is the definition that I currently use. I'm all-inclusive because I think it's all interconnected. However, I do think the precursor should be a solid object because I don't think we need to include quartz after gas bubbles. Geodes don't, that's not, no. And so with that, I would like to thank those that provided insight and assistance with this project, and I will take questions.
Thank you so much, Erin. That was very comprehensive, very well researched, very interesting. Are there any questions for Erin? Brian.
How much did nationalism play in these parallel lines of thought?
I think that's a very interesting question. I think it's probably, there's good chances that the Cold War interrupted communication between the American scientists and the Russians. This is all it boils down into material sciences in the end. These were war topics. So, I mean, I think you have a divergence of the sciences, and I don't know that they've come back together yet.
Is there potential for, I guess, a similar series of Russian works going back 100, 200 years?
Oh, I'm sure there are, and I would love to look at that. The problem that I'm going to run into with some of this is the German and the French translations were easy enough because I can recognize the characters. Once we get into different alphabets, it's just a lot more difficult. I am sure that there's more work and we can't access it because you can't get, there's no translations.
So what are you going to write in the history of the thermodynamics?
I don't know.
Let me don't want to be this thing is from the perspective of chemistry and thermodynamics. None of the classifications suggest that you make much difference. It's the actual chemistry that drives the EH and pH. So I'm really fascinated on all that works. I mean, I'm not at, I write some perfect work wrong. How does that actually work?
Sure. I will tell you, my scientific background kind of doesn't exist. So I try to look at it and try to make sense of it. I've been trying to figure out what Frondel is talking about for years now, and I'm not sure if I just don't understand it or if it's because it's, you know, almost 100 years old now. It's something I need to work on, but I try not to go too far into the science because I don't want to butcher it.
That is a very interesting point, that we're kind of looking at physical characterizations of what we see without thinking about process. Interesting way of, yeah, thinking about this. Anne.
So I'm just curious, after looking into the history of the pseudomorph terminology, do you think other terms under the umbrella like epimorphs and paramorphs and all that are really necessary?
I've stopped using them.
Okay.
I don't think they're helpful. And I think honestly, a lot of times they're confusing. You know, the problem with epimorph is to have an epimorph, you also have a paramorph. But how do you tell the difference between a paramorph and a paramorph? It's like, could you guys have come up with better names? It's really it's really confusing. I don't think it's helpful. I just use incrustation and then it's either solid or hollow past that, and that covers it. I've stopped using a lot of the little subterms. In my book, they're all pseudomorphs and you can differentiate some subtypes, but I just
Makes it
conclude all of
easier to
it.
Label your specimen.
Yeah, it really does.
Yeah, and I noticed in your cases at the museum, yeah, everything was just
Yep.
pseudomorph, so I was curious.
Yep,
Yeah.
that's what I do,
Yeah.
you know.
If
Other
any of
people
you
are welcome
didn't
to do.
see Erin's cases at the museum last night, or if you just got here today, go check them out at the museum while they're there. She's got an amazing pseudomorph collection.
Thank you.
Yeah.
Thank you.
Yeah, how did you get into collecting pseudomorphs?
You know, it's funny. The first specimen I ever bought was a pseudomorph. I met Calvin Webb at the Farmington show and he started telling me about different transformations in minerals and it absolutely blew my mind and I just haven't really stopped since.
Nice, thank you.
Are there any other questions for Erin? Yes.
Has anybody ever produced a video of a pseudomorph form using computer graphics?
Not that I know of, but that's an interesting idea. To some degree, you almost might even be able to produce a real video of it happening under lab conditions. It's a lot of these don't take an extraordinary amount of time. You know, they've been able to, with the last pegmatite symposium, there was a video of some of those crystals forming that was absolutely fascinating. You could hypothetically produce a real video. I don't know of anybody who's done that though.
Are there any other questions? Well, with that, let's thank Erin again.